the derivative is defined only at one position. So the derivative dy by dt is therefore the limiting value of delta y by delta t. What's the meaning of this again? The delta y by delta t in a big interval, we call this is the average rate of change in that interval. And when you make the interval shorter and shorter and shorter and shorter, when the delta t is so small that it's very close to zero, the value of delta y by delta t at that time is called dy by dt, the instantaneous rate of change of y with respect to t. And look at the way we write that in calculus. Dy by dt is the limiting value of delta y by delta t when delta t approaches zero. In the limiting case, when delta t approaches zero, delta y by delta t is called dy by dt, which is the derivative of y with respect to t, and it is a measure of the slope of the tangent line drawn at the point A. That's right. This animation is from the University of Minnesota Math Department, and it shows how when the interval is made smaller, how the secant line eventually becomes the tangent line at this point. You can see the secant line, this is the average rate of change. The average rate of change becomes the instantaneous rate of change. Is that right? The secant line becomes the tangent line when delta t approaches zero. There you are. And that is an important concept in calculus. Now, here is another animation. I'm going to drag this red point and change this interval. Now, when this interval is made smaller and smaller so that delta x become equal to very close to zero, see what happens. This is the secant line now, and see how when the interval becomes smaller and smaller, how the secant line becomes almost the tangent line. You notice now the interval is so small that this line is now almost a tangent line at this point, and the slope of that line gives you the instantaneous rate of change at that instant, at that position, at that. Alright, let's now look at the symbols that we use one more time. The derivative of x with respect to t, what is the definition of that? It's the limiting value of delta x over delta t. Delta x over delta t is the average rate of change in an interval delta t. The limiting value of that when delta t approaches zero is called dx by dt, the derivative of x with respect to t, and we represent that by x prime. In other words, dx by dt is the same as x prime. Similarly, limit delta t approaches zero, delta y by delta t is dy by dt, and we also write it as y prime. The average rate of change of y with respect to t, the limiting value of that when delta t approaches zero becomes the instantaneous rate of change. The slope of the secant line at that instant is called the derivative of y with respect to t, or y prime. Similarly, limit delta x approaches zero, delta y by delta x, this time the independent variable is x, is dy by dx, is also called y prime. Now, very often we use the symbol, whether it is with respect to t or with respect to x. So we need to specify the independent variable. The derivative of a function f of x with respect to x, we represent it as f prime of x. So f of x is the function, f prime of x is its derivative. Alright. Now, how do we find the derivative of a function? We just talked about it. If y equal to 10x, what is the rate of change of y with respect to x? We found it is 10. If y equal to 20t, then delta y by delta t, or dy by dt, in that case will be 20, because the function is a linear function. Now, if f of x represents the function of x, then when x changes to x plus delta x, now look at this, when x equal to x, the function is f of x. Is that right? Just like when you work for 2 hours, the output is f of 2 equal to $20. So when the input is x, the output is f of x. Now the input is going to increase by a quantity called delta x. So this interval is delta x, so that this input value is x plus delta x. Now when the input is x plus delta x, the output is f of x plus delta x. Have you understood that? When the input is x, the output is f of x. When the input is x plus delta x, that means the input is now greater. The output becomes f of x plus delta x. In other words, when you say f of 2 equal to 20, f of 4 equal to 40. Is that right? So here, the input is x plus delta x. The output is f of x plus delta x. Now tell me, what does this quantity represent? F of x plus delta x minus f of x. That represents the change in the function value, the change in the output, or we can say the increase in the output in this case. A change is a better word. So f of x plus delta x minus f of x is a measure of the change in the function value or a change in the output, and we represent that by delta y, the change in the output. And this change in the output occurs when the input changed by delta x. So this is the change in the input, this is the change in the output. Delta y by delta x is the change in the output divided by the change in the input. The output when the input is x plus delta x is f of x plus delta x. The output when the input is x is f of x. So this output minus this output is your delta y. And that is a measure of the slope of the secant line, and we generally call it the average rate of change. And so the average rate of change is f of x plus delta x minus f of x all over delta x. So this is the average rate of change of this function from x equal to x to x equal to x plus delta x in that interval delta x. Alright, now this is a measure of the average rate of change in the interval delta x and is equal to the slope of the secant line. We talked about it. And this average rate of change becomes instantaneous rate of change when? When does this average rate of change becomes the instantaneous rate of change? When we make that interval very small, close to zero, when delta x becomes very, very close to zero. In other words, the limiting value of this ratio. And therefore, we say instantaneous rate of change is the limiting value when delta x approaches zero, the change in the function value divided by the change in the input. The change in the output divided by the change in the input. The limiting value of this when delta x approaches zero is what we call the instantaneous rate of change. That is, the instantaneous rate of change is the derivative of the function. If the function is f of x, its derivative is f prime x. And f prime x is a measure of the instantaneous rate of change. And it is obtained by the change in the function value divided by the change in the input. And we take the limiting value of it when delta x approaches 0. So look at the definition again. F prime of x, the derivative of f of x, is limit delta x approaches 0, f of x plus delta x minus f of x, that's a change in the function value, divided by the change in the input value. The change in the output divided by the change in the input, and we find the limiting value of that when delta x approaches 0. Let's practice this using a function like this. F of x equal to 2x plus 5. Now tell me, if I have a function like f of x equal to 2x, what is the rate of change? Well, we know that, we talked about it. It is 2. When x changes by 1 unit, y will change by 2 units. How about f of x equal to 2x plus 5? Let's use the definition of derivative. So our function f of x is 2x plus 5. How about f of x plus delta x? The input is now x plus delta x. Means replace your x by x plus delta x there. So if f of x equal to 2x plus 5, f of x plus delta x is 2 times x plus delta x plus 5. Now, distribute there, it will be 2x plus 2 delta x plus 5. Now, what is the change in the function value? That is f of x plus delta x, which is this quantity, minus f of x, which is this quantity. So that will be f of x plus delta x is this, minus, that's right, this is your f of x plus delta x, and minus your f of x is 2x plus 5. Now simplify this, distribute that negative sign, you get this. And you notice 2x minus 2x plus 5 minus 5 will go. What is left? That's equal to 2 delta x. So the change in the function value is 2 delta x. Alright, let's divide this change in the function value by delta x. What do you get if you divide 2 delta x by delta x? Delta x will cancel. That will give you 2. And you can see the average rate of change is 2. What is the instantaneous rate of change? Because 2 is a constant, the average rate of change and the instantaneous rate of change are the same. Why? Because the graph of this function is a straight line. There is no difference between average rate of change and the instantaneous rate of change. A difference occurs only when you have a graph that curves up or curves down. Then the average rate of change and the instantaneous rate of change are different. And one more thing I want you to notice. The derivative of f of x equal to 2x plus 5 is 2. And the derivative of f of x equal to 2x also is 2. That means this constant number really does not play a role in the derivative of a function, because a constant does not change. Is that right? Alright. Therefore, we say limit delta x approaches 0, delta y by delta x equal to 2, or f prime of x equal to 2. The derivative of this function equal to 2. Let's practice the same with another function. Look at this. F of x equal